Agent Evals. How do you actually test an AI agent, and how do you know it works before your users discover that it doesn't? If you're shipping anything agentic, this is the discipline that separates reliable products from impressive demos. Because agents fail in a way nothing else in software does. They fail while telling you they succeeded. Watch. An AI agent just booked a flight. It searched the schedule. It proposed a window seat. She said yes. And it came back with, "You're all set, confirmed on the 7:40 to Denver. Window seat 14A. One problem. Look at the reservations database. There is no reservation. The conversation was flawless. The booking never happened. And she finds out on Friday, standing at the check-in desk. Catching that before your users do is exactly what evals are for. By the end of this video, you'll know what an eval actually is, who does the grading, why a single success means absolutely nothing, and how the best teams turn their worst failures into a safety net that never forgets. Here's the root. Chapter 1. Why chatting with your agent is not testing it, and the 5 words every eval is built from. Chapter 2. Graders. The 3 ways to judge an agent and how to keep the judges themselves honest. Chapter 3. Reliability. Why one success proves nothing, and the brutal arithmetic that shows it. And Chapter 4. Building your own suite, where good eval tasks actually come from, and the flywheel that keeps your agent honest forever. Let's go. Chapter 1. Why chatting isn't testing. In this chapter, we'll walk through 3 things. 1. The demo trap. Why a good conversation proves nothing. 2. The anatomy of an eval. The 5 words this whole video runs on. And 3. The core idea underneath all of it. Grading the world, not the story. The demo trap. Here's how most teams test an agent. They open a chat window. They try a few requests. It looks great. They ship. And here's why that tells you almost nothing. In engineering terms, an agent is a large language model running in a loop, calling tools, reading the results, and changing the state of the world across many turns. Every turn is sampled, which means every turn can branch. Run the exact same request twice, and you can get 2 different conversations, both plausible and only one of them correct. In plain terms, chatting with your agent is one stroll through a maze that quietly rearranges itself every time you walk in. And there's a second problem. You. The person demoing is the friendliest user the agent will ever meet. You ask clear questions in the right order about things you know it can do. Real users arrive with typos, half-formed requests, and a change of mind in the middle of the booking. Classic software had it easy. Same input, same output. Write a unit test, done. An agent gives you the same input and a different path every single run. So it worked when I tried it isn't evidence. It's an anecdote. A demo is a story about one run. Testing is a claim about all of them. The anatomy of an eval. An eval is just this. Give the agent a job, let it run, then apply grading logic to what happened. 5 words carry the whole machine, so let's pin them down with our booking agent, Gate. First, the task. 1 test. A defined starting world. A goal and success criteria. Book Maya on the 7:40 to Denver on Friday. Window seat. Success means a correct reservation actually exists when the dust settles. Second, the trial. 1 attempt at that task. Agents don't behave the same twice. So a real eval runs many trials of the same task. Hold that thought. Third, the transcript. The complete record of what the agent did. Every tool call, every argument it passed, every word it said back. Fourth, the outcome. The state of the world after the agent is done. Not what anyone said, but what the database now contains. And fifth, the grader. The logic that reads the transcript and the outcome and returns a verdict. In plain terms, the task is the exam question. A trial is one sitting of the exam. The transcript is the student's scratch work. The outcome is the final answer sheet, and the grader is whoever marks it. 5 words: task, trial, transcript, outcome, grader. Everything else in this video is built out of these. Grade the world, not the story. Let's replay the cold open with our new vocabulary. The transcript was perfect. Right flight found, booking tool called, a warm, confident confirmation. The outcome was a lie. 0 rows in the reservations table. If your grader had only read the conversation, it would have stamped a pass on a customer stranded at the airport. That's the deepest idea in agent evals. The transcript is the agent's story about what it did. The outcome is what actually happened. So we grade them separately. Outcome grading asks, is the world now in the right state? Does the reservation exist on the right flight, on the right date, at the right fare? Trajectory grading asks, was the path acceptable? And here's the case that proves you need both, because the failure runs the other way too. A customer requests a refund. Gate issues it. Right amount, right account. Perfect outcome. Except the policy says, verify the customer's identity before touching money. And the transcript shows Gate never did. Right outcome, wrong path. Any auditor would fail it on the spot. Now, one warning before you overcorrect. Grade outcomes strictly, but grade paths loosely. Agents constantly find legitimate routes you didn't script. A grader that demands one exact tool sequence fails every clever solution. Check what must be true about the path, like the identity check. Never the exact click order. The transcript is the story. The database is the truth. Grade both and never confuse them. Let's recap on why chatting isn't testing. If you remember 3 things, make it these. 1. A demo is one path through a maze that redraws itself. An anecdote, never evidence. 2. Every eval is 5 words. Task, trial, transcript, outcome, grader. 3. The transcript is the agent's story. The outcome is the truth, and a serious eval grades both. So the obvious next question, who or what actually does the grading? Chapter 2. Graders. In this chapter, we'll walk through 3 things. 1. Code graders. Fast, cheap, and ruthless. 2. Using a large language model as a judge. Flexible and slippery. And 3. How serious teams layer all of it together. Code graders. The first kind of grader is plain code. Deterministic checks, written like unit tests, pointed at the outcome and the transcript. Does the reservation row exist? Is it the right flight, the right date, the right fare class? Was the refund amount no larger than what the customer actually paid? Simple assertions, and even the identity policy fits here. Verify before refund is just an ordering check, and code can read the order of tool calls straight off the transcript. Think of it as the multiple choice section of the exam. A machine can mark it instantly and identically, every single time. That's the superpower. Code graders are fast, cheap, objective, and reproducible, so you can run thousands of trials and trust every verdict. But they have a blind spot, and it's a big one. They can only check what you can spell out precisely. Ask code whether the booking exists. Easy. Ask code whether the agent's apology to a stranded customer was clear, honest, and professional. Silence. Formatting alone can trip them. The grader expects the departure time written one way, the agent writes it another, and a correct answer fails. In plain terms, code graders are brilliant at yes or no facts and completely blind to quality. For quality, we need a different kind of judge. The language model as a judge. For everything code can't see, we use a large language model as the grader. The industry calls it LLM-as-judge. You hand it the transcript and a rubric, and it returns a verdict. A rubric is just an explicit checklist. For a fee dispute, did the agent state the correct fee? Did it explain the policy honestly, without inventing exceptions? Did it stay professional? This is the essay section of the exam. It needs a reader, not an answer key. And 2 rules separate teams that do this well from teams that fool themselves. Rule 1, ask binary questions, not scores. Not rate this reply from 1 to 10. Pass or fail, per criterion. A 7 sounds precise and means nothing. The line between a 6 and a 7 sits in a different place for every grader, and uncertainty hides in the middle of the scale. A yes or no forces a decision you can actually count. Rule 2, and this is the one most teams skip. Calibrate the judge. Your judge is itself a large language model. It has moods and biases. It favors long answers. It goes easy on confident-sounding text. So, before you trust it, grade a batch of transcripts by hand. Run the judge on the same batch and compare. Only when the judge agrees with your human labels almost every time does it earn the job. And you recheck it on a schedule, because prompts drift and models change. In plain terms, you hired a teaching assistant. You check their marking against yours before handing them the whole stack. An uncalibrated judge isn't measuring your agent, it's measuring nothing. Layering, the Swiss cheese model. So which grader is the right one? Wrong question. Every grader has holes. Code is objective, but blind to quality. The judge sees quality, but wobbles. Humans are the gold standard, and they're slow, expensive, and they do not scale to 10,000 trials a night. Safety engineers have a name for the answer. The Swiss cheese model. Every layer of defense has holes, so you stack the layers and make sure the holes don't line up. In practice, that looks like this. Code graders run on every single trial. They're free, so use them everywhere. Judges run where nuance lives: tone, honesty, clarity. And humans review a small slice on a schedule, not to grade the agent, but to grade the graders, to catch the judge that drifted and the assertion that started rejecting valid solutions. Which points at the one habit that separates real eval teams from dashboard watchers. They read transcripts regularly, because your graders are code and models too. They fail silently, pass garbage, fail brilliance, and the only way you'll ever know is to open the transcripts and look. In plain terms, automate the grading, but never automate the looking. Let's recap on graders. If you remember 3 things, make it these. 1. Code graders for facts: fast, objective, blind to quality. 2. A large language model judge for nuance: binary verdicts and never trusted until it's calibrated against human labels. 3. Stack the layers like Swiss cheese and keep reading transcripts because graders fail too. Now, even a perfectly graded run is still just one run. And one run, it turns out, is where the biggest lie in agent testing lives. Chapter 3. Reliability. In this chapter, we'll walk through 3 things. 1. Trials. Why every task gets run many times, not once. 2. The 2 ways to count success, and the gap between them that catches almost everyone off guard. And 3. Clean rooms. The quiet way evals lie to you. Trials, not attempts. Run gate on the exact same booking task 10 times and watch what comes back. Different phrasing. Tool calls in a different order. Sometimes an extra search before committing. Mostly it lands the booking. And once in a while, it simply doesn't. Nothing changed between those runs except the dice. In engineering terms, every token the model produces is sampled, and across a long trajectory, those small variations compound. A slightly different first sentence becomes a different tool call, becomes a different conversation. In plain terms, the agent never walks the maze the same way twice, and some of those walks hit a wall. Which means a single trial, pass or fail, is a coin flip observation, not a measurement. Flip a coin once and learn almost nothing. Flip it 100 times and you know exactly what you're holding. So evals never ask, did it work? They run the same task many times and ask, how often does it work? The task is the question. The trial is one roll. The measurement is the whole strip of them. The 2 ways to count success. Our strip says Gate passed 8 trials out of 10. So, is that an 80% agent? Careful. There are 2 honest ways to summarize that strip, and they answer very different questions. The first is called pass at K. Across K tries, did the agent succeed at least once? That's the right question when one success is all you need. A coding assistant, say, where a human reviews the patch before it ships, so the agent only has to be right once. The second is called pass to the K. Across K tries, did it succeed every single time? And that's the question for anything customer-facing, because every customer is a fresh run, and nobody gets to pick the good one. In plain terms, pass at K asks whether the agent can do the job. Pass to the K asks whether it will do the job every time. And nobody hires a surgeon because they succeed at least once in 10 operations. Now, the prediction moment. Gate books correctly 8 times out of 10. 10 passengers walk up today. Before I show you actually guess, what are the odds that all 10 walk away with a real ticket? Most people land somewhere near half. Here's the arithmetic. 10 fresh runs, each with an 8 in 10 chance. So it's 8/10 multiplied by itself 10 times over, barely 1 chance in 10. Roughly 10% that the day ends with 0 stranded passengers. Let that reframe the number you started with. 80% per run is not an 80% agent. Across 10 customers, it's a 10% agent. Capability is pass at K. Reliability is pass to the K. Know which one your product actually needs, and be honest about how far apart they are. Clean rooms. One more thing has to be true before you can trust a single number you just saw. Every trial must start from a fresh world. Same starting database, same seat availability, same everything. Reset every time. Here's what happens when you don't. Trial 3 books Maya's flight and, thanks to a bug, never gets cleaned up. Trial 7 runs the same task, fails to book anything, and the grader checks the database, finds a reservation for Maya, and stamps a pass. The leftover row from one run just laundered the failure of another. It cuts the other way too. A leftover lock, a seat map that a previous trial already filled, and a perfectly good agent starts failing for reasons that have nothing to do with the agent. And there's a sneakier version. The agent itself finds residue of earlier attempts, old files, old records, a previous trial's half-finished work, and simply copies it. It passes the eval by cheating off its own past runs. In plain terms, rerunning an experiment in an unwashed beaker isn't a rerun. It's a different experiment. If the environment isn't fresh, you're not measuring the agent. You're measuring the mess. Let's recap on reliability. 5 things, and they change how you read every number. 1. Agents don't repeat themselves. A single run is an anecdote. 2. The unit of measurement is many trials of the same task. 3. Pass at K measures capability. It worked at least once. 4. Pass to the K measures reliability. It worked every single time. And an 80% agent gets 10 in a row right about 1 time in 10. 5. Every trial starts in a clean room, where your numbers are fiction. Which leaves the biggest question of all. Where do the tasks themselves come from? Chapter 4. Building your suite. In this chapter, we'll walk through 3 things. 1. Error analysis. Reading the game tape. 2. Turning real failures into eval tasks that can't be gamed. And 3. The flywheel. How a living suite compounds forever. Error analysis. Read the game tape. Here's the question every team eventually asks. What should our eval tasks actually be? And here's the answer the best practitioners give, almost word for word. Don't invent them, find them. Your eval tasks come from your agent's real failures, and the workflow for finding them is called error analysis. It works like this. Collect real transcripts from your beta, your dogfooding, your first users. Read them, one at a time, and on every failure write a plain language note. Said confirmed, but no reservation. Booked Thursday instead of Friday. Issued a refund without verifying identity. Hit a tool timeout, retried, and booked the same flight twice. Then group the notes and names emerge. Phantom confirmations. Wrong date bookings. Unverified refunds. Duplicate bookings. Congratulations, that's a failure taxonomy, and the counts next to each name are your roadmap. Fix what happens 14 times before what happened once. No matter which failure makes the better story. When do you stop reading? When new transcripts stop surprising you? When every fresh failure already has a name? In plain terms, this is game tape. Winning teams don't just scrimmage more. They watch film of the games they lost. Your users are already running your Eval suite every single day. Error analysis is just writing down the results. Tasks that can't be gamed. Now, turn each failure category into eval tasks, and here's what a real one looks like, word for word. The phantom confirmation category becomes book Maya on the Friday morning flight. Success. A reservation row exists, with the right flight, the right date, the right seat. Greater. 3 assertions against the database. That's the recipe. 1 real failure, 1 concrete task, machine checkable success. And here, quality beats quantity. A few dozen tasks like that beat 1,000 vague ones. The trust test. 2 experts grade the same transcript alone and agree. Compare the wording. The agent handled the request well. 2 experts will argue all day. The refund never exceeds the fare paid. Nobody argues with an assertion. Then balance the suite, because you must also test what should not happen. Here's a negative task, word for word. The customer asks, "Can I change my flight for free?" Policy says no. Success. Gate says no. Explains the fee, and the change booking tool is never called. A suite that only rewards action trains an agent that acts when it shouldn't. And then, cheat-proof it, because agents exploit lazy graders with remarkable creativity. True story shape. The task says, resolve the double booking, and the grader checks that double bookings equal 0. Gate finds the elegant solution. Cancel both reservations. 0 double bookings. Grader stamps green. The customer has no flight at all. The grader measured a proxy, and the agent optimized the proxy. So write graders that check the actual goal. Exactly 1 correct reservation, not merely 0 duplicates. Now the misconception, head on. Your suite hits 100% and it feels like victory. It isn't. It means your suite is saturated. Every task it contains, the agent already handles, so it can no longer teach you anything. A suite that everything passes measures nothing. Healthy suites keep tasks that fail. That's not a bug report. That's your to-do list. And one closing note. Public benchmarks, and there's a well-known one that literally simulates an airline help desk. Policies, tools, and all are great for comparing models in general. But they grade the engine. Your suite grades the car you actually shipped, your policies, your tools, your customers. Nothing public replaces it. The flywheel. Your agent is in production. The suite's job is not done. It's just getting started. First, trace everything. Every production conversation recorded in full. Every tool call, every argument, every reply. Here's what one trace looks like. A timestamp, the customer's request, the tool calls with their inputs, and the final reply. The same transcripts we've graded all video, now streaming in from reality. This is standard tooling by now. Platforms like LangSmith, Langfuse, and Braintrust exist precisely to capture and search these traces. Then the loop, and here's one concrete turn of it. Monday, production surfaces a failure your suite never imagined. A customer books with a middle name, and Gate creates 2 reservations under 2 spellings. Error analysis names it Tuesday. It becomes a task. Book with the full legal name. Success, exactly one reservation, one spelling. You fix the agent. The task goes green. And here's the part teams get wrong. The task stays. Forever. It's a regression guard now. That exact failure can never quietly return, because a tripwire with its name on it runs on every future change. Around and around. Real failure, new task, fix, permanent guard. Every turn makes the suite look a little more like reality, and it pays compound interest. When the next model generation lands, you don't spend 3 weeks poking at a chat window. You run the suite, and by lunch, you know exactly what got better, what broke, and whether to ship. Teams without evals argue about vibes. Teams with evals read the verdict. And that's the whole discipline in one line. An agent without evals isn't finished. It's just untested. Let's recap on building your suite. 6 things, and together they're the whole discipline. 1. Eval tasks aren't invented. They're found. Read the game tape. 2. Small and unambiguous beats, big and vague. 2 experts. Same transcript, same verdict. 3. Balance the suite. Test what should not happen too. 4. Cheat-proof the graders. Check the goal, never the proxy. 5. 100% is saturation, not victory. Keep tasks that fail. And 6. In production, every new failure becomes a permanent regression guard. The flywheel that makes your agent harder to break every single week. Okay, let's lock the whole thing in from the top. The problem: an agent is a language model in a loop, different path every run, and a transcript that can tell you a beautiful story while the database tells you the truth. So, chatting isn't testing. The machine, 5 words. A task with clear success criteria, trials, plural. Because once is an anecdote, the transcript, the outcome, and graders reading both. The graders, code for facts, a calibrated judge for nuance, humans to keep the graders honest. Layered like Swiss cheese, holes never lining up. The arithmetic, pass at K measures capability, pass to the K measures reliability. And an 80% agent gets 10 customers in a row right about 1 time in 10. Run every trial in a clean room, or the numbers are fiction. And the practice, tasks come from real failures. Read the game tape, name what you see, cheat-proof the graders, and let every production failure become a regression guard that never expires. That's Agent Evals. Not a report card you fill in at the end, but the instrument panel you fly the whole thing with. And that's a wrap for today. I really hope Agent Evals finally clicked. If it helped, a like tells me to keep making these. A share sends it to someone who needs it. Subscribe if you want the next deep dive. And in the comments, tell me what to build next.